So if we think about a two-dimensional array, we can think about two different sized arrays. Either it's going to be even sized or odd sized, but we can note that the middle index on the odd sized is going to be the actual middle of the two-dimensional array. However, when we look at an even-sized array or a two-dimensional array, the two center columns are considered the middle together. So if we go through our algorithm to figure out how to determine this, we have to split it up into two parts. First, we have to determine whether something is even or odd sized, and we can use the remainder function to calculate the remainder of the division by 2 for the size, because if we know the remainder, a remainder of a division by 2 of 0 means that it's even sized. But if there is a remainder, then it will be 1, indicating that it's odd. So when it's even, we know that two middles exist. So we can divide by 2 to find the left middle, and one more than that will give us the right middle. Otherwise, it's going to be odd sized, and only one middle exists. So we can't simply divide because we will get decimal. For example, 7 divided by 2 will be 3.5. Our middle is actually 4 when we have size 7. So we can simply round that decimal up. And MATLAB has a ceiling function, ceil, that gives us the ceiling of a number, rounding it up. When we take 7 divided by 2 and round it up, or call the ceiling function on the result, we end up with 4. Let's jump into MATLAB and code it. So on the right side of our window, we have the algorithm that we just went over. Then we have the command window, and we have some items set up in the left side of our window that's just an array, one of even size and one of odd size, and where we want to store the middle spots. So the first thing we're going to do is set up a length variable and get the length of the X array. Then we want to get the remainder of the array size divided by 2. So when it is 0, we will perform the two middles scenario. And the first middle is on the left side, and so we get array size over 2. Then the right middle is just one more than that, and we store those in an array left and right, two values. In the other case, we have an odd-sized array, so we simply take the ceiling of the division statement, the array size, divided by 2, so that rounds the division statement up and gives us the middle of the array, the middle index. Then we want to display it out. So we see in the command window, when we execute, we get the middle spots of 3 and 4. Highlight those, right? So 3 and 4, get rid of those. And if we change to Y, we can run it again. And we see 4 is the index we get. If we change it back to X, we can run it again, and we'll see 2 and 3. And then if we add some things to X, we can run it one last time to see that 4 and 5 are again. So 8, 6 are the elements, but we get the indices of 4 and 5 in our middle spots. So that was an implementation of the finding middle for a one-dimensional array. Similar strategies can be applied to finding the middle of a two-dimensional array, except you'd have to apply it to the rows and the columns to find both dimensions.